Okay. Linear regression. So, really big math term, but it doesn't mean as anywhere near as bad of a thing that you think it is. Linear regression is a line of best fit. So I'm going to give you a data set in a table of values or a scatter plot. And you're going to have to put that data into your calculator to figure out if I were to draw a straight line that best represents this data, what would that line be? And that line would be in slope-intercept. And remember, slope-intercept form is y equals mx plus b. But your calculator doesn't represent m how you think it will. It's supposed to represent m with a. So technically speaking, it's y equals ax plus b. And we'll get into that in a second. So I narrowed the steps down a little bit for you, but I kind of combined a couple. So generally speaking, there are two steps to this data. Step one, okay, so on your calculator, you are going to go to press stat, okay? And I went ahead and just pressed stat for you. You should see something that looks like this. Okay. And then you're going to just press enter because you're already on edit and choice one. Okay, so when you do that, you're going to see a table of values like that. It's probably hard to see. So it doesn't matter if you have L1, L2, or L4, L5. You're just going to enter the data in exactly how you see it. So here are obviously my X values. Make sure that you put them in exactly that order. Okay, don't jump around. And don't order them from lowest to greatest. That won't help the process. And then enter in your Y values as your next section or the next column. Okay. Once you do that, you're going to press stat again. And you're going to go over to calc. Now you see a whole bunch of things there. Right now, the only thing we need is choice 4, which is linreg ax plus b. I'm going to go down and choose that. Okay. Press enter. And now I have a bunch of stuff you don't have. You're just going to keep hitting enter until it actually calculates for you. Okay, and you see how it's blinking right there. So I'm going to calculate that. Now, I've got a whole bunch of stuff there. A represents the slope, as it does in slope-intercept form. B represents the y-intercept. And there's another letter that we talked about yesterday, and that is R. R represents the correlation coefficient, and we'll get to that in a second. Now, if I am going to ask you to, I don't really want to use green, kind of want to use green, it's better. I just actually opened it, so it's better. I want to write the slope-intercept form of this line, and I'm just going to round to the 100th to make it a little bit easier for you. So it's y equals, and the calculator says A is 1.1285, blah, 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 blah. So I'm just going to round it to 1.13x. Okay, that's the slope of that line. It's just a little bit more than 1. Okay. B says 0.194. Okay, so I'm just going to leave this 0.19. So plus 0.19. That's the y-intercept. That's where the line pretty much starts. Okay, so on that y-axis. Good. Now, it says here R. That's the correlation coefficient. And if I'm just going to round to the nearest 100th, it's 0.88. Okay. We talked about correlation coefficients ranging from -1 to +1. Okay, so let me just erase this top part so you can see it a little bit easier. So correlation coefficients are from -1 to 1, and then obviously zeros in the middle. Okay. So if it's 1, it's a strong positive correlation. If it's -1, that's also a strong correlation, but it's strong negative. Okay? And if it's 0, there's absolutely no correlation here. Spelled that wrong. So correlation means how well does the line of best fit the data. Okay, so if I were to make a scatter plot of this, a 0.88 correlation coefficient means it's pretty strong. It means that if I drew that line physically, it's going to pretty much be in the middle of all these points. So it's going to represent it really well. Now, let's say the correlation coefficient was like 0.01. It'd be like right around here somewhere. That means that this is a terrible correlation. It's not good at all. It doesn't represent the data at all. Now, also, being 0.88, or on the positive side, that means the slope is going uphill, which also represents this slope as being a positive slope. Now, if I had a -0.88, it's a strong negative correlation. Still going to fit the data really well, but then the slope would have been a negative slope. It would be going downhill. Okay? So linear regression, we're actually going to do a lot more steps of this before the test next week. But take a look at this video a couple of times, stop it as you go along, because I want you to get this part down. This part's really, really important, okay? So strong negative, strong positive, and we also call things that go next to 0 as weak. Now, it can be weak positive, and it also can be weak negative, but just get your vocabulary down right to make sure that you understand linear regression.